Hi, welcome. My name is Hannah Omis, and this is a presentation of the physiological functions of the body and how they are affected by exercise. So first, it's important to define physiological functioning. These are the mechanisms that occur in the body that make it, enable it to operate, to move, to act. These are usually automatic. For example, when the heart rate speeds up to increase blood flow, when a person starts running, or when a person starts shivering. When they're cold, it makes the muscles warmer and heats the body up. So the more that such mechanisms occur, the easier the body can make them happen. And that's why you'll find it easier to lift the same weight or run the same distance or perform the same dance routine the more you do it. So what are the factors that enhance physiological functioning during exercise? We have two categories here, outside factors and personal factors. The outside factors are things like the ambient temperature. This affects the way the body handles heat. If the outside air is cooler than the body, it's easier for the body to get rid of the heat caused by active muscles. The blood takes the body from the core and brings it to the surface of the skin where it can, um, through conduction, go out into the atmosphere. Also, a good warm-up improves physiological functioning because it prepares the body for more intense movement. There is a note that says this may be partially psychological, but it's been shown that the body can work harder and longer with less stress if it's been properly warmed up. Consistent training improves how much oxygen your lungs can uptake. This is referred to as VO2 max. A person's VO2 max increases with aerobic training and decreases if training stops. So the higher your VO2 max, the more efficient your muscles are, and the more capable you are of sustaining effort in an endurance event. So specialized training helps because the body learns by repetition. A cyclist trains by cycling, a swimmer trains by swimming, but that shouldn't be the only training because varying training types like anaerobic versus aerobic exercise or weights and cardio is better for injury prevention and overall health. Personal factors. These include things like proper hydration, proper nutrition, personal level of training, and your psychological mental state. Proper hydration is important because your muscles must have water to function. A lot of water is lost in sweat, even when the weather is cool, and often more water is lost during workout or competition than can be replaced at one time because your stomach can only process a certain amount of water per hour, and that amount is lower than what the body needs during high intensity effort. So it's important to be hydrated before exercising. Nutrition, the same. It's essential to physiological functioning. Every movement the body makes is fueled by food, and if the food a person consumes contains too much or too little of the necessary nutrients, it can cause distress, dysfunction, reduced ability, and in extreme cases, or if it's like chronic, death. And this is referred to as malnutrition. Personal ability and level of training enhances physiological functioning once the training starts to take effect. So as I mentioned before, all parts of the body become better at doing what you make them do. And as for psychology, your mind and your body are more connected than you might think. Your psychological state and what you think about during exertion affects your body. So whether it is positive or negative effect depends on you, on your personal mental state. So as for physiological functioning that's limiting, it's kind of the converse of the benefits. So the same things that enhance performance can cause limitations on the reverse side. So being too hot, being too cold, not having enough water, not eating right, and then exercising at altitude. When you're not used to it, it can limit your physiological function because there's not as much oxygen in the atmosphere. So you're not breathing it, and the gas exchange system of the body that brings oxygen to the muscles and carries carbon dioxide away doesn't have enough oxygen to work with. When you're resting, this isn't a problem, but when you're exercising, it can have a negative effect especially if you're attempting an endurance event. So while you're resting, your body doesn't have to do anything. So physiological adjustments happen that make the heart rate slow down, blood pressure decreases, body temperature reduces. There's still a certain amount of energy that is used to keep your body functioning, but it's a far lower rate of energy usage. And the longer your body is at rest, the more exercise capacity is lost, such as muscle strength or the level of VO2 max. So like if you're ever on bed rest, you lose a lot of your muscle conditioning. When the ambient temperature is cold, however, the body's heat mechanisms increase to maintain body's core temperature. So blood flow to the surface of the skin decreases to reduce heat loss, and if that's not enough to maintain body temperature, the body starts shivering to make the muscles produce heat. And conversely, in the heat, blood pressure and heart rate both increase, and blood flow to the skin increases to help carry away excess heat. All of that in a nutshell is basically the body gets better at doing whatever you make it do on a consistent basis. So here's an interesting quote. Heat generated by active muscles can increase core temperature to fever levels that would incapacitate a person if they were caused by external heat stress alone. So the body produces a lot of heat, especially while exercising. When you breathe in oxygen, it's called oxygen uptake, provides oxygen for active muscles, and then active muscles generate heat. During exercise, this can be beneficial because warm muscles work better than cold ones. But if there is too much heat in the body, it becomes heat stressed. It won't function as effectively, and you can even experience illness or death. The body has several mechanisms for distributing heat off and away from the core. And the first of these I already mentioned. The blood carries heat to the surface of the skin where it can disperse into the atmosphere. Another one is a mechanism we're all familiar with, which is sweating. Skin that is wet with sweat is high in potential evaporative cooling. How much cooling actually happens depends on relative humidity and wind. Some heat is also dissipated through breathing or when you're panting. There's a lot of water loss through respiration though, so hydration remains key in handling heat in a healthy way. So in conclusion, physiological functioning is best described as changes in the body that have to do with adapting as best as it can to whatever the current situation is. These physiological changes can be immediate, but they can also be long-term changes as the body overcomes challenges to its equilibrium and adapts over time. The factors that influence physiological function during exercise have a lot to do with how well the body is conditioned and how well it is cared for. The factors that influence physiological function during rest are similar in that the body adapts to rest and can lose the conditioning gained during exercise. Also, depending on the weather, physiological adaptations are similar to those in activity, such as heart rate, heat metabolism, and blood pressure increase. Finally, heat is produced through oxygen uptake, which passes to the muscles, generating energy release and heat. Thank you for attending to this presentation. Here are my references.